Alright, we're getting ready to test the heating system for safety and efficiency. So I'm going to turn my back rack on outside so that it zeroes out to fresh air, which should theoretically have 0 parts per million of carbon monoxide. Typically takes 60 seconds. And we are going to find out what the outside temperature is, because that's what we use to calculate our minimum draft pressure that we need for the systems that are atmospheric. And my temperature, 37 degrees. So then we use this formula. Okay, I'm zeroed out. We can go inside. We don't have to stand out in the cold anymore. So I used the calculator on my phone. Oh, let me give some light. That's a calculator on my phone here. I'll clear it. 37 divided by 40 equals minus 9.25 minus that magic number 2.75. So I get a minimum draft pressure of minus 1.825. So I write that down. And now is where I would usually get the homeowner to help me by closing any windows and doors that are currently open. We've already checked and all the windows are closed, but we're going to close that front door behind us. And now we're going to make our way to the thermostat. We're going to note what temperature it was set for. We set it 63. I'll write that down. And then I'm going to crank this thing way up, and I'm going to immediately walk down to the basement, and I'm going to find the system switch to disable it. Alright, so I get right over here, and right on the side of the boiler is this thing that just looks like a light switch. Sometimes this box is red, you know, it has like a, yeah, it looks red. I've turned it off. So what that means is now when I'm ready to turn this on, the thermostat's already calling for heat. I have it cranked way up high, and when I turn this switch back on, this boiler will come on when I want it to. So now we're going to identify what's going on. The sheet has places that we're going to circle things and make check marks. We want to write down the person's name. It's Chris Nichols. The site ID, you will have gotten that from your home energy specialist, 5020038. You want to write the date, including the year. So it's the 7th of March, 2017. So now we're identifying the systems. So I've already asked these guys, they're getting pretty good at identifying stuff. So it is a boiler. It is fired by gas. So the ways that you figure that out, this is your gas line, this nice black pipe. There's a gas valve down there. You don't have a big oil burner hanging off the front. So it's a gas-fired, atmospherically vented. We've got a chimney here that these metal flue connectors hook up to, so that means atmospheric. You can see, in the case of the water heater, the draft opening, that draft hood, that little bell-shaped thing right down here at the base. This is where air mixes in. For the boiler, we'd have to get around the back there to see it, but there's a box off the back of it that has an open, it's open on the bottom. And that is your draft hood for the boiler. So up inside there is where the combustion gases are coming out of the top of the combustion chamber, and you poke your back rack way in there to get it where it's not diluted, so you get a raw sample of the carbon monoxide. So we can check off that, number one, both of these are atmospheric, so that's that first column all the way over on the left where it says induced and atmospheric. You make a check mark in the row that says heating system, check mark in the row that says hot water. We've got a separate water heater, which means that it does burn gas. You circle yes, you circle gas. The only times, so if you would circle no, it would be because this was an indirect store that has no heat, no burner in it, or it was a tankless coil, which would mean that the water heating is integrated with the boiler itself. It's got that tankless coil inside of it. So we have checked atmospheric, so what that means is that it's not any of these other vent materials. It's not B-vent, it's not PVC, it's not stainless steel. You could go ahead and circle no for all of these too if you really want to be double clear that it's not any of these things. It is galvanized, which means it's safe for us to drill holes. Atmospheric means it's negative pressure, so we're wanting to measure for draft. and it's safe to drill holes in galvanized with an atmospheric system. So now we're going to go through and look at some of these to answer these questions in the safety check section. Are there any open returns in the combustion appliance zone? So open returns are only where you have a furnace, and this is not a warm air furnace, this is a water system, so there's no open returns. I am able to smell the thing they add to natural gas that would tell me if there was a lot of unburned natural gas down here. I don't smell any of that. I do smell a little bit of paint varnish. I would warn the homeowner that it's not safe to have things that are flammable in a combustion appliance zone. But there's no unburned gas. There's not a gas leak going on down here. So I would circle no. Are there any broken, corroded, or detached vent pipes? I've looked at these vent pipes. This is what we're talking about when we say vent pipes, the metal connections between the combustion appliances and the masonry chimney. These are called vent pipes or flue connectors, and they're in perfect condition. There's no corrosion on the vents. I don't see any corrosion on any of the water pipe connections anywhere. This equipment looks like it's in pretty decent shape. Another thing we look at, and when we get into a combustion appliance zone, we look at how the flue connectors are sloped, if there's enough upward slope. The boiler has a really good slope. This has a pretty good slope. It needs to be a minimum of 1/4 inch of rise for every foot of run. So this probably just meets that. This
a little
one,
tight, right?
Yeah, this one definitely meets it. All right, so we make a note about the condition of venting, and it's good. There's no problems here. The next thing is sort of a unicorn, a gas atmospheric equipment with no draft hood or more than one draft hood. Probably not going to see that. So, and it's not going on here. So no. Unvented gas on gas oven or other space heaters. You will see some unvented space heaters occasionally. People have gone over the border to New Hampshire and buy them. You're not allowed to buy them in Massachusetts. You're not really allowed to use them here. It's against code. You might see them every once in a while though. What you won't see very often is what's called a gas on gas oven. That's the old oven that you see in some of the older triple deckers where the source of heat was part of the oven. It's like one whole section of the oven that's just heating, and then the other tiny little section is what you can put like a Cornish game hen in when Thanksgiving comes around, because the cooking part of the oven is really small. So no, we don't have any of those in this house. And then we want to keep our eyes open as we're walking around to see if there's a working carbon monoxide detector. And there happens to be one right here, right over Bree's head. That is hardwired, kind of sketchy. Nobody's got it hanging out of there, but that's a carbon monoxide detector that definitely is working, because every once in a while I see this LED flashing, so it's hooked up to power.
I might call it soft wired because it's hanging so low.
Yeah, it's kind of dangling there. But they do have a carbon monoxide detector, so I circle yes there. All right.
Functioning carbon monoxide detector. Very important.
We are getting ready to measure baseline pressure. So I've got a hose already taped up in this window. It's out to the outside world. I have my manometer here, and I'm going to put the hose on the, first of all I'm going to turn the manometer on. Sometimes what you want to do is you want to zero this thing out before you hook the hose up. So you have a button over here on the right, you can press it. You want to make sure this is sitting still. You don't want to be holding it in your hand and waving it around when you do this. So now I got a 0, so now I'm going to go ahead and hook up my hose. And what I'm getting here by going on the right hand side is I'm leaving the reference open to the room that I'm in, and I'm getting the pressure in the combustion appliance zone with reference to outside. And so I'm looking at a number that's a lot different than 0, and it is a negative number. Sometimes it bounces around a little bit because it's windy, but I've been watching it. It's been getting anywhere between this -3.3 and about -4.6. So I kind of take an average in my head and I go, all right, -3.8. So I'm going to write that number down. Okay, so now what we're going to do is we're going to make the house fight the atmospheric venting. We're going to create what's called worst case depressurization in the house. So we've done some things with the interior doors already. We've closed all the interior doors that lead to rooms that don't have exhaust fans in them. So regular bedrooms, our bathroom in this house does not have a bathroom exhaust fan. So we've closed off those rooms that don't have exhaust fans in them. And now we're going to go around and we're going to turn on anything that exhausts to the outside, including dryers, bath fan, kitchen fan, range hoods. So we're going to do that. We have gone around and we've made sure that any interior doors that do not have exhaust fans on the other side are closed. We've left the other interior doors open. The basement, the door at the head of the basement stairs and the door to the kitchen here are open because this range has an exhaust fan. So I pressed this once. That doesn't sound strong. Pressed it again. It sounds stronger. I know this only has 2 settings. Some have 3. But we get this going at its highest setting. And now what we're going to do is we're going to work our way backwards into the combustion appliance zone. And we're going to determine whether the doors between this and the combustion appliance zone want to stay open or closed. And the easy way to do that is to use a smoke pencil. You could also go downstairs after you close one and see if it makes the pressure on the manometer more negative with it closed or open. It's a lot easier to do it with this. So I'm going to be getting on this side of the door, if you want to join me.
And we're testing this because there's competing exhaust fans.
Exactly. We have 2 things that are exhausting in this house. One of them's up here. It's this kitchen exhaust fan. And we also have a clothes dryer downstairs, which we've already turned on. And we're going to see which one of these exhaust fans is winning the battle. What is making the worst depressurization for the combustion appliance zone. So that's why I back myself into the combustion appliance zone, and I'm figuring out which one of these doors has to be open or closed as I'm backing my way into the combustion appliance zone. All right, so come on back down this way.
Uh-oh.
Most of the time, you can sort of intuitively figure this out, but if you ever have a quality control Competitive Resources Incorporated guy, CRI, watching you, they're going to want to make sure you know how you know what's creating the worst case depressurization, the worst case that you can get with the house. So being able to smoke a door, you watch the smoke. Again, I'm on the combustion appliance zone side. That's why I literally back myself into the combustion appliance zone. And so when you're on the combustion appliance zone side of the door, you can use the phrase that if the smoke blows in my nose, I'm going to keep the door closed. Well, right now the smoke is blowing away from me, so that means that this exhaust fan in the kitchen is winning the battle. It's creating more of a depressurization for the combustion appliance zone than that dryer is. So I'm going to leave that door open. I'm going to do the same smoke test for this the door at the head of the basement stairs. It also is doing the same thing. So open it is, and now we back our way down into the combustion appliance zone again. Don't try this at home, don't walk backwards down the stairs, but so far the door from the basement has been left open, and this door from the combustion appliance zone is going to want to be left open because the smoke is blowing away from me, it's not blowing in my nose. So that's what we did to create the worst case depressurization for this combustion appliance zone that we're now standing in. And so what we want to look at now is what's our number after we did all that, and it is a more negative number than what we had before. So we have a minus 4.6. And so going from minus 3.8 to minus 4.6, our total depressurization, or our total change in pressure, sometimes it's pressurization, you can increase pressure in the summer sometimes, usually not. Total change in pressure is minus 0.8. So I write that down. Now we're done using this manometer for this purpose. So I'm just going to leave that hose right there. Now that's where I've written my numbers. All right. So now I'm going to disconnect this, and I'm going to set it down back over here, getting ready for what comes next. So now remember, we've turned off the switch for the heating system so that we can get it to turn on when we want to. We would drill the holes that we need for this test. They happen to already be drilled, but in the case of the domestic hot water heater, and they're actually all behind here, in the case of the domestic hot water heater, we're not going to need to drill a hole for carbon monoxide because we're just going to measure that by getting our probe down inside here before air mixes in. We would drill a hole up here after this elbow, which I'm feeling for right now. It's right here. It's like right here. I know it's back there.
Yeah, we can see it.
Yeah, and that's where I'm going to measure for draft. Right. For the boiler, if you come around behind here, I think we already did point this out. Yeah, Bree was back here with the camera before. The boiler has a box on the back of it that is the start of this flue pipe here, and this box is what we would call the draft hood for this boiler. So I'm gonna be testing the carbon monoxide by pushing my back rack up inside here before air mixes in, and then I'm also going to test for spillage right at this draft hood opening, and then I'm going to test for draft right here after the elbow of that atmospheric steam boiler. So I'm going to put my light here so we can see what's going on back here eventually.
If homeowners ever give you trouble with the drilling because they're concerned about the hole, as long as the flue's not hot and it's firing, I like to just stick my hand up in here a little bit and be like, see the hole already?
There's a big hole right over here.
You can feel comfortable with it.
Yeah.
It's just fine. Air is a normal part of the way the system works.
Yep. So we've drilled the holes, actually they were already drilled. So now what we're going to do is we're going to mark the dial for the domestic hot water tank to make sure we can set the temperature back to where it was before we got here. It's already marked here. And what we're going to do is get ready so that we don't waste any time. And I'm making sure I'm all caught up. I've written everything down. Yep. Oh, so we want to write down what we did to create the worst case. So we have one clothes dryer. We have no bath fans. We do have a kitchen exhaust fan. We have no air handler. And what we ended up with, the most important doors that we ended up with, are the basement and Kaz doors are both open. Okay. So now I'm getting ready to test for spillage and draft on the smallest BTU per hour appliance, the one that is the smallest, meaning it doesn't do a very good job of heating the big masonry chimney up by itself. We start with this one first because if it's going to fail drafted spillage, it most likely would fail drafted spillage when it's at that disadvantage. It's the only thing going into the chimney. So we start there, and then we turn this off. We turn the boiler on. We test it for its spillage and draft to see how it does without this helping. And then we leave the boiler on, and then we come back, turn this back on again, and we test this for spillage and draft again to see if the boiler being really hot, the big brother over here, being really hot and helping to heat up the chimney, helps the draft and spillage situation. All right, so that's going to be the flow. So I'm going to need to get at it. About 60 seconds now. Ready? All right, listen for it. It just turned on. You can hear that roar. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And I can see that smoke is not being pulled up into that flue, into that draft hood very well at all. And we want to wait 60 seconds. It's been 25. 26, 27, 28. You can even just feel with your hand. I feel warm exhaust pushing back out against my hand. That smoke's not really being sucked sideways into that draft hood very well.
How far away do you need to have it?
I like to, if I can, I like to have it right underneath where it's right on the dividing line. So it's either going truly one way or the other, right? And it's wavering back and forth. It's kind of looking like it might start to pass, but it's really now it's really close to 60 seconds, right? So it's not getting pulled in, it's just moving straight up sideways next to that draft hood. It's not being pulled in, and now it's been 60 seconds. So I'm going to say I'm circling no for that domestic hot water heater. There's a place on our sheet where we circle the no.
Now, in order for it to pass spillage, does it need to go all the way around 360 degrees?
Absolutely. If you find that it passes everywhere but one corner, it's still a fail, right? So that's why you saw me go 360 degrees around. So now, while it's running, now we don't have much time. I'm back here because the hole is back here, and I am putting the hose to my manometer on the left side now because I'm measuring the pressure directly. I'm not measuring it with reference to anything else. And so remember, we calculated a minimum draft pressure. We wanted to get a negative number that is a more negative number than minus 1.825. So I wait for this to settle down. I put it right into this hole. I look at my number, and I've got like a minus 1 point. So it's looking good. The draft is looking good. The draft is looking like minus 2.2. All right, so I'm going to write that down. Now I'm going to turn my boiler on. Minus 2.2, I write down for the draft for the domestic hot water without the heating system going. Now I'm going to turn the switch on for the boiler. I'm going to come back over here with my I'm going to turn this back down so it's not interfering or influencing what's going on. So the domestic hot water tank is now turned off. Boiler is on. We're giving it 60 seconds from right now. I just heard it turn on. We get the same thing. We kind of hold this down below the line right at which that box, which we call the draft hood, is. I'm right under it, and you can see the smoke is getting pushed out. I can also feel with my hand that there's hot exhaust gas pushing down against me. That should not be happening. The flue gases should be going up the chimney, and I should feel cool air going by my hand on the way into this box, and that's not happening. This is spilling like crazy. So we can go for another 40 seconds. I can tell you I've done the combustion safety testing in this house a number of times, and this thing does fail spillage under worst case conditions.
Now, same thing with this. Would you be moving the smoke stick and trying to see if it passes
I would,
on all sides?
absolutely. But I saw it failed one place, so I really, I know it fails because it fails anywhere. It fails.
Once it fails, it
ultimately.
fails.
Yep.
But you do give it the full 60 seconds. Now,
Yep.
why does it have 60 seconds to pass spillage?
So what will often happen is the equipment has to heat the flue up, the metal part and the chimney to a certain degree, to get the draft to start up. So we give it 60 seconds to give it a fair chance. Sometimes you'll turn things on and it'll pass right away, right? And you could sit there for the other 60 seconds and it's still passing. But other equipment might take almost all 60 of those seconds to turn the corner and start to pull away the way it should. This is not. And it's been 60 seconds, so this is failed spillage as well under worst case conditions. So quickly we'll measure the draft for this boiler. Now sometimes you get passing draft, but you get failed spillage. It's still a fail, right? So we've got a number that's minus 1.3 or 1.4, 1.5. This has had enough time to really warm up to get a good draft going for itself. And it's still not passing because the number we calculated, the minimum number, is the minus 1.825. We're not there. We're at minus 1.5. So I write that down. Now I'm going to turn the domestic hot water tank back on, and we're going to see how it does with the help from our big brother here. So Bree's turning that dial up. We wait till we hear that whoosh. Don't hear it yet. Sometimes we got to go turn some hot water on to get it to go at this point. Yep, I got to go run up and turn on some hot water right now. Can't come on. We had to turn some hot water on upstairs in the kitchen to get it to go. So now we got 60 seconds. And we've still got so you can see it's kind of almost half and half here, but it really wants to be all going in to pass. And it's just not really.
Are you saying almost doesn't count?
It doesn't count. Almost isn't, almost passing isn't passing. We really want to see that smoke getting sucked in, like sideways, into that draft opening. And we don't want to feel any hot exhaust coming out here. Sometimes you'll have tanks that have the cold and the hot water color indicator rings, the rubber rings up here, and they'll be melted. because the spillage is constant here. It melts that stuff because there's exhaust pushing out and melting that stuff. And it's still, it's been pretty close to 60 seconds, and especially on the back side. Now it passes over here, it's doing what I want. It's getting pulled sideways into the draft hood over here, but as soon as you go over onto this side, not so much. Nope.
Now, while we're doing all this testing, we have
60.
these combustion appliances going.
Yep.
Should we be paying attention to our ambient CO?
Absolutely, and that's why I've had this thing running over here. And in the combustion appliance zone is where you're going to get you're going to get some ambient after the appliances have been on, right? And
Especially if they're spilling.
Yeah. So I've been here before, and there's enough of a draft that it's not building up in here. So you're not getting much of an ambient in this area. All right. Now let's measure the equipment. So we've got the boiler itself. Oh, by the way, sorry. We got spillage fail with the boiler helping. The draft for your domestic hot water is actually not as good as when, so the boiler running hurts the water heater a little bit. Now it's actually getting pretty close to the same. So minus 2.5 for the draft on the domestic hot water heater with the boiler helping, right? So that's that second spot, minus 2.5. And now we're going to measure the carbon monoxide in the boiler. So I'm going to push my back rack probe way back up inside here. I'm going up into the draft hood, and I'm reaching the probe, the metal part, back up to right over the fire. And
want to test the CO in the boiler first or the hot water system first?
You could really, it doesn't really matter. The carbon monoxide is what it is. Like the one being on doesn't so much affect the other. Like the one affects the draft and spillage of the other. So you could do this carbon monoxide test in any order you want. I look at the numbers, and so I can look at the oxygen percentage to see when it stops moving around, or I could look at the temperature, the stack temperature, to see when it sort of stabilizes. And once things stop moving around, and generally after something's been on for 5 minutes, you're going to get the carbon monoxide level that is the steady state carbon monoxide level. Or you can also look at the steady state efficiency percentage that's right down there below the carbon monoxide part per million number. And for steam boilers, that number there, that efficiency number, usually not much better than 82. And now our temperature has stabilized, our oxygen percentage has stabilized, numbers have stopped moving to a certain extent, and so I can say that the carbon monoxide is 6, right? So I'm going to go ahead and write that down. Now you got two choices for testing the water heater carbon monoxide. You got to get down below where air mixes in, right? And so I have this little device that it's an adapter that makes a copper hook onto, with a hose, hook onto my back rack probe. And so I can take this and I can turn it sideways, move it in here to where I can turn it down so that I'm getting the exhaust before the air mixes in. So I have that copper tube down inside the exhaust opening here. Now that exhaust opening has a divider in it, and so we need to get the measure on both sides of that divider. And so that's why your form has two places to write carbon monoxide numbers, right? So I'm getting a 1 on this side. That number has stabilized. All right, and then I take this, turn it back the other way, come back from this side, poke it in there. This is a really tight one. That's why I have to do it where I go from one side and then the other. Most of the times you can get both from just one side. You just turn it, then push it back to the back side, turn it around again. But on this one I have to do something different. So I'm also getting a 1. So I'm going to write 1 and 1. And I'm going to take this thing out of here. And we are done testing for spillage, draft, carbon monoxide on both of these units so we can start to turn things back to normal, right? So I turn this back to where it was set before.
Some people like to leave their keys with the hot water heater.
Yeah.
Because you don't want to scald the homeowner because you forgot to turn the hot water down.
So we've had all our stuff has been running for some time now, and I now have my back rack probe laying on the floor to cool it off, and I'm also getting the ambient in the air, and it's down to 0. It went down to 0 almost right away. So that's good. So that's a number we also have to write down on our sheet. For the combustion appliance zone, the ambient is 0. All right. I'm going to turn the boiler back off again. And it's still at 0, so that's great. I'm going to check my, make sure I've circled everything. Very important, we have to give the information about what the vent termination is. So the actual vent termination for our equipment is all the way up at the top of the chimney. So that means that our vent termination is inaccessible, yes or no? Our vent termination is inaccessible, yes. It's all the way up at the top of the roof and we're not going up there. So then what it vents to is the chimney or roof. And that's for both of the pieces of equipment. So the domestic hot water and the boiler, the heating system, both of their vent terminations are inaccessible, yes. Both of them vent to this chimney. So I've made sure I've filled everything out here except for the things that we have left to do. So we have a dryer that is fueled by electricity. The way you can tell that is you look for this big plug. This big electric plug indicates it's electric. Even though they have gas in the house, they've not made this gas yet. There's no gas line behind here. You'd also, you know, if you had gas, it would be, you know, one of those yellow flexible connections perhaps, or it might be black cast iron pipe, just like they use for the equipment in there. So we have an electric dryer, so we cross off this little box and then we write electric in the corner. Now, because things failed under worst case conditions, with the house fighting as much as it can, with the depressurization happening, what we would want to do is we'd want to turn these things back down, let them cool off, we'd go back upstairs, we'd turn off the kitchen exhaust fan. The dryer already turned off for us. And then after everything's cooled off down here, we would start all over again and test for spillage and draft for this one first, turn it off, turn the heating system on, test for spillage and draft on that one, leave it on, come back, turn this back on, test for spillage and draft on the domestic hot water tank to see if, under natural conditions, without the house fighting as much as it was, any of these appliances pass. So we're not ready yet to circle pass-fail down here. So there's a little bit more work to do. But for right now, we're going to go upstairs, let this stuff cool off, and we're going to test the oven, which does burn natural gas. We're leaving this on the entire time, so we're measuring the ambient throughout the course of the visit. We'll go upstairs and we'll actually be measuring. I'm going to check inside the oven. I'm going to make sure there's nothing in here that can melt. Sometimes people store their pots and pans in there that have plastic handles. A piece of aluminum foil on the bottom can interfere with things. We might need to remove that, especially if it's caught a lot of pizza drippings. Just want to get rid of that. Say, sorry, this is how I'm going to get an accurate test. You can put a fresh piece in there after I'm done, or they might say take it and set it aside and reuse it, you know, whatever. But we want to make sure there's nothing that can melt and anything else that will interfere with our test. And we're going to preheat this oven to 500. Every oven's different. Sometimes I got to ask the homeowner, how the heck do you turn this thing on? This one's weird. You press this bake temperature button and then you use this knob to dial in the temperature you want. So I'm going to dial in 500 degrees. What I would not recommend you do is do not poke this probe into the exhaust the second you turn this thing on, because ovens generally spike with carbon monoxide. We want to measure what the carbon monoxide is after it's had a chance to get to steady state, which when you preheat it, but I poked that in there for a second and it was above 100 parts per million, and I just went down. So I'm kind of waiting, I'm hoping that this oven ultimately will have a number that's less than 100 parts per million. So what that means is, for mass save, what we end up really doing is if it's between 100 and 300 in here, then we write a disclosure that says it's not a roadblock to work, but you want to get your oven cleaned and tuned to get that carbon monoxide in the exhaust as low as it can be. And then the ambient is going to be as low as it can be, and it might actually be 0 out here. I'm going to go ahead and try again. And there's only one place where you're going to get a reading, and that's this right here. I'm going side to side to the sides of this little exhaust thing. It's a really thin slot. And now I'm looking at the carbon monoxide number, and it's not climbing up really, really fast. It's, you know, it's getting up. It's going to go above 100, but now what I'm going to do is I'm just going to leave this in here to see that part per million number start to drop back down. There we go. So now I leave it, and I watch it get closer and closer to 100. Once it gets below 100, pass. Oven passes. We're not done yet, though, because we still have to figure out whether, under natural conditions, our heating and water heating will ultimately pass everything. It remains to be seen. So when we got up here, before we turned the oven on, the ambient level in the living space was 0 after we had had all our heating stuff and water heating stuff running downstairs. And if it's 0 in the combustion appliance zone, generally you're going to get 0 up here, around 310. So it's not even done preheating yet. It's not even gotten to the best steady state efficiency, and it's already below the threshold. So we know the oven passes. And so, now what I'm going to do is I'm going to give that a little bit more time, but I'm going to measure what the ambient is out here. Let that be right there.
Now it's dropping really fast.
Yeah. And it's below 35 in the room. Now we want to make sure it gets down below 9. That's our next milestone. And really the worst the ambient is going to get to when the oven is running is as it's been warming up. It's only going to get better now. If it's getting better here, it's getting better out here generally. And so we're already down below 9 ambient after the oven's been running and doing the worst it can do. 6, 5.
So would you call the system good now?
I would, and to be honest with you, I might not stick around for as long as it takes for this to really stop dropping. I might not stick around for as long as it takes for this to actually say it's all the way to 500 degrees. Once it passes, it's going to get nowhere but better. It's going to get nothing but lower in the carbon monoxide in here and out here. I want to be ready. That's all I had left. Tiny little nub. And we do the same sequence as before. I have this turned off so I can turn it on when I need it, this being the power switch for the main heating system. I have this dialed all the way down, the temperature. I'm going to turn it up.
Now you want to be careful you don't turn that too far down, right?
Right, exactly.
I've had a couple home energy specialists put it to pilot and then...
The pilot light goes out and then they got no hot water. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Look at that. Remember it was failing miserably on this corner, and now it's doing great. That smoke is getting sucked sideways right up into that draft hood the way we like to see it. So under natural conditions, all by itself, after the flue has had a chance to cool down, we're getting better results here, here, all the way back around here. And it's not even 60 seconds yet. So this only gets better, honestly. You're not going to start to have failed spillage later. It's only going to get better. So that passes that. So we circle yes, passes spillage under natural conditions for our water heater. So far, actually, you know what? We circle that after we've tested it all different ways to Sunday, right? Not done with that yet. But now we're testing the draft on our domestic hot water tank. I have my manometer still sitting back here, and I run that into the domestic hot water flue. Look at my number. I've got a better negative number now. House isn't fighting as hard. So I got a minus 6.9 or minus 7.1-ish. Minus 7.1. So I write that number down. Over here on the right-hand side. So that's why we have these two columns. We've got the worst case on the left that we've done already, and now we're over here on the right side, the natural conditions one. We've got that minus 7.1 draft with just the water heater going. So now we turn this down again. Wait for that to turn off. We turn our heating system back on with the power switch. And we can hear some things happening. It doesn't fire up right away because it's got some safety checks to do. There we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Looking better. So the smoke is getting pulled sideways a little better. It's still not stellar, but definitely better than before. Right? I'm kind of right down on the line to see which direction it goes, in or out. It's kind of wavering between. Remember, we got to give it 60 seconds because it may be heating up the flue enough to create a good draw for itself, and it's not done with that yet. But it's really close. It's been about 20 seconds or so far here. Not stellar. I can feel hot down here, so I know it's not perfect. It's definitely spilling over here on this side that Bree can't really see very well. It's getting pushed out away. Can you see it?
Oh, a little bit.
Yeah. See that? I'm directly below the line and it was going off to the side. Here, it's still, I'm actually holding it inside and it's being pushed out a little bit. So you get to be pretty good at using this to really tell you what's going on, the visual indication. So it's been about 60 seconds now, and I'm not ready to say that this passes with flying colors on spillage under natural conditions. As it's billowing out to the side, it's kind of going back and forth. It wants to be getting sucked in. I should be able to hold this pencil a couple inches, like maybe 4 inches down and a couple inches out, and I should be able to see that smoke getting sucked in. It's not, right? So it's really just not. And I can feel hot exhaust gases pushing down against my hand. Some people use a mirror to see if the fogginess happens. That is still failing spillage under natural conditions. Now let's find out what the draft is. You will see that draft can pass, but spillage will still fail. It's still a fail. Because draft passed all ways so far. The water heater was close to failing under worst case. Sorry, no, the heating system was close to, it did fail under worst case by minus 1.25, minus 0.125. Yeah. But so far under natural conditions, the draft for everything is A-okay. And again, you see that, but spillage is still spillage. All right, so now we've got the furnace, the boiler running, the main heating system running, and now we want to see what its influence is on the water heater again. So we turn this back on again. Sometimes it will help, sometimes it will hurt. All right, so now it's on. I heard it come back to life. I'm going to get my smoke pencil out again. I just put my hand here. I don't feel as much hot coming out at me, and this is definitely moving in the right direction. So this was where it was at its worst before, you know. and it's turning the corner the way I like right away, right? So it's been about 5 seconds. It's getting sucked sideways all the way around. This is a passing spillage. See what I'm saying? Like I got my smoke pencil out here and it's getting sucked in sideways. Yeah. That's passing. When it's kind of making up its mind and you hold it right underneath and it's kind of going back and forth, that's failing, right? If it's not definitely getting sucked in, it's failing. So this is good. This is passing under natural conditions with the heating system running. Now we measure the draft. Bree's got it. We got a minus, wow, nice and strong now, minus 11. Minus 11. And so the water heater passed under natural conditions both ways, when it was by itself and when it had the heating system helping it, but the heating system still failed spillage under natural conditions. I've tested carbon monoxide under both, and I've always found the same numbers. Like that doesn't change, so you could literally just copy these numbers right to the side here, right the same ones you had before, and you're good to go. So that means even under natural conditions, we got a fail here, right? Yeah. All right. So we circle fail. Well, we let the home energy specialist circle fail when you're a tech running with your home energy specialist, and the home energy specialist is the one that writes the initials there. So now, before I leave, I'm going to make sure I've filled out all the rest of my numbers so that I can present this combustion safety sheet to the home energy specialist so he can double check things, make sure I haven't missed circling things or checking things, or if he sees something that doesn't quite make sense, he may come back down, check it out with you, ask you a few questions, just verify what we got is what we got. But that's pretty much it, and that fail is going to be what gets circled in this house.
Thank you very much.
All right, thank you.
Rob Eisnick, ladies and gentlemen.